Hello and welcome to another video from Ellensburg Amplifier Repair and Service. My name's Todd and we have a Taramps Smart3 here that I wanted to go over real quick. I already started working on this and I decided I'm going to shoot a video on this real quick. So this goes right into protection. When you first try to start it up, it just goes right into protection. So my initial testing saw that I wasn't getting any rail voltage. So obviously there's no drive to the power supply. So what I do is a really quick, simple process. You will find the meter readings right here in the top corner there for you. This is coming off my UT, my UT61E Plus meter hooked up to the computer here. And what I'm going to do is I'm just going to show you gate to source values. And again, I'm one of those techs that uses resistance because it really defines what's going on outside of the transistor for me. So I'm really not looking for internal issues of the transistor, because typically transistors, when they fail, they will fail either one of two ways. Visually, you can see that they've burned up, or two, they will show as a dead short. So when you see the transistors, they're not physically damaged, nothing's burned up on the board, I just go right to resistance mode and I just check gate to source, and you'll see I have 590, well, roughly 99 ohms. That's one bank. The other bank I have, as you can see on the meter, 1K. So what is that telling me? That's telling me, well, I have a problem on this side, because I know that I'll show you here, I have 1K pull down resistors to ground. So there's a 1K pull down resistor. And over here, we're going to have the same 1K pull down resistor, although you're going to see that it's not going to come up. Well, as soon as I find the 1K here, it's not going to come up as a 1K, because something is, I wouldn't call it is shorted, but something is definitely out of tolerance. So these are real similar to the, what is it, the MD3K, the HD3K? Hold on, just give me 2 seconds. Yeah, so these are real similar build to the HD3Ks. So let me give you a real quick rundown on how this is put together. You have 12 volts coming in off your main battery, goes around, pops up over here on the other side of the transformer. Again, this is really the same as the HD3Ks. Pops up through a via here, goes through a 4.7 ohm resistor right here. And then through this 4.7 ohm resistor, which you can see is missing right here, and there's a reason why it's missing, comes up and around and feeds 12 volts to your gate drive IC here. Now your gate drive IC is directly connected to ground. So pin 3 of your gate drive IC, as you can see, is directly connected to ground. And 3, 4, 5, I think it's pin 6 is going to be your gate drive. Let me just double check here real quick. 7, 1, there it is. Pin 7 is your gate drive for the suspected bad bank. So pin 7 goes back to the gate drive. So if you measure from pin 7 to pin 3, you're going to see your 600 ohms. You should see your pull down value of 1K. So let me fire up the ST862 hot air gun here real quick here. Let me pull that IC real quick. It'll take just a second. Please excuse the noise from the hot air here. So I'm just going to pull this IC off. And we'll show you the values after the IC is removed. All right. Now I'm going to make sure none of my solder pads are shorted together. Looking good. Sorry as that hot air gun ramps up to cool down. And now what we're going to do is I'll show you by removing that gate drive IC, you'll see that we now see, if I can get my probes on there, you'll see I have my 1K pull down values. 1K exactly, 1K exactly. These Taramps boards use 1% resistors, so I know they're pretty close in value. So there's our 1K pull down. And if you were to go back and measure the resistance across your gate drive IC, you'll see that 600 ohms across the gate drive IC. The HD3K that I just fixed had a 2.7 ohm short in the drive IC. So again, the resistance values tells you what's going on behind the scenes of the transistor. Let's see. Now, if I had that IC still on the board, I could probably show you the diode mode of that, but it's very rare that I use diode mode on your transistors because, again, transistors either fail drastically or they're still good. Very rarely do they fail open, and when they fail, they will physically be blown apart. So when I see that, I automatically go to resistance. I check the gate drive behind the transistors, and sure enough, I'll find the bad drive IC. And then usually when the drive IC goes out on these, you gotta go back to the 4.7 ohm resistor that feeds that 12 volts. Let me show you the value of the 4.7 ohm resistor that I pulled off of the board. And on that 3K, the HD3K that I just did, that 4.7 ohm resistor was literally blown apart. So, because it had a dead short. So here's that 4.7 ohms reading 43.59 ohms. So that's the resistor feeding the 12 volts to the drive IC. So on these HD3Ks and the Smart3s, when you don't have power supply drive itself, go back, check your drive IC, and then don't forget to go back and check your 4.7 ohm resistor, because this one didn't look burnt open, but it was definitely out of value. So you want to make sure that the circuit that feeds that drive IC is 100% and good to go. And that's pretty much all that's going to be wrong with this particular amplifier, is just that failed gate drive IC. So what I'm going to do is I'm going to put a new 4.7 ohm resistor on, put a new gate drive IC on, and I will bet money that this will fire right up, just like the HD3K that I literally just fixed. I changed those two components, put power in, amplifier fired right up. These gate drive ICs run hot, so they do have a somewhat high failure rate. Sam at Bear Vids, I think previously in one of his videos, mentioned you could probably glue a small little heat sink on these gate drive ICs just to help dissipate the heat of the gate drive IC, which isn't a bad idea, but I'm just a warranty repair person for these guys, so I just replace the components, obviously, that are failed on it. So maybe in the future I might stock these small heat sinks, and I just might glue one on just for longevity of the amplifier in the future. So I'll probably look into that. So thank you for watching, guys. I just wanted to go do a quick review on these Smart3s. Again, the same as the layout for the power supply drive as the HD3K. Watch that drive IC, and don't forget that 4.7 ohm resistor. Thanks for watching, guys. If you have any comments, leave them down below. I'll get to you as soon as I can. And be safe, watch the rail voltage, and I'll catch you on the next one. Thanks for watching.